Hello, and welcome to another installment of our online learning. We are going to be looking at relative area today. And so I wanted to give you a little background in terms of what all of this, how this all relates to probability in our study. So we are going to be looking at today in particular geometric probability. And what that is it's the probability of an event happening corresponding to the ratios of different areas of figures. So today what we're going to be looking at is figures that have a shaded region. And so I thought an easy example would be to show you the three examples that you see on your notes, which are these spinners. So if you think about a spinner, and let's look at the one on the left, for example. It is shaded half of the way, so the probability of landing, that spinner landing on the gold or yellow area would be 1/2. And then if you looked at the next one, you've got 3 out of the 8 pieces that are shaded, so that probability would be 3 out of 8. And then corresponding to the last example of 1 out of 4, you would land on that blue area. Now we're going to take it a step further and look at how these relate to different geometric properties and different figures. So we're going to scroll down, and you can see that I've included some area formulas for you to help you as you look at these different figures and try to calculate what portion of it is shaded and what portion is not. So I thought I would run through an example with you of something that kind of looks like an envelope. So if you were to find out what the probability of, let's say, landing, if you were like throwing darts, let's say, landing somewhere in this mint green area. So like if you were throwing a dart somewhere in this area, we're trying to find what's the probability of that happening. So what we need to do is we need to use our area formulas to find the area of each individual object that you see. So if you think about this, I'm going to highlight this in blue. We are looking at one large rectangle and we're also looking at a triangle. So what we need to do is we need to find the area of each of those geometric objects. So I'm going to go back to my blue, and if I'm trying to find the area of this rectangle, if I look at that chart, to find the area of a rectangle, it's simply length times width. So if I look at my measurements, my length is 10 inches. And my width is 5 inches. So I'm going to multiply those two numbers together, and so I will get an area of 50 inches squared. Now let's take a look at that red triangle that we outlined. So the area of a triangle is the base times the height divided by 2. So I need to find what my base is. So this area right here would be my base. So if I look at my rectangle, I see that this side is 10 inches, so therefore this also needs to be 10 inches. And so I have my base, and then I have my height. So my base is 10 multiplied by my height of 3, and I need to divide that by 2. So I get an area of 30 divided by 2, which is equal to 15 inches squared. So in order to find the relative area or the probability of landing somewhere in that mint green area, I need to find the portion of the rectangle that's shaded. So to do that, we are going to subtract the area of the large rectangle, the blue rectangle, and then we're going to subtract the area of the red triangle. So to find the shaded area, and then we're going to be dividing that by the total area. So to find the shaded area, again, we said we were going to subtract 50 minus the 15. And then we're going to put that over the total area, which we found was 50. So let's go ahead and simplify that. So 50 minus 15 gives us 35. And then bring over the 50. And then we just need to simplify. So since these both end in a 5 or 0, I'm going to divide both my numerator and denominator by 5. So I get an answer of 7 over 10. So 7 over 10, I need to change that not only from a fraction, but to a decimal and a percent. So my decimal equivalent, if I think about this, I would say this fraction is 7/10, which looks like this as a decimal. But I could also calculate that in my calculator. I could do 7 divided by 10 and still get 0.7. And then if I want to change this to a percent, I just need to multiply my decimal by 100, which means I move my decimal point 2 spaces to the right. 1, 2. So that would give me an answer of 70%. So that would be my relative area, or my probability of landing somewhere in this shaded region. So I am going to have you go ahead and work on these following problems for your relative area practice. And then also included is some IXL practice in finding the area of shaded regions. I will also include the answer key for the relative area practice so that you can check your work. And then if you have questions for me at our next check-in for Google Meet, just make sure you star those problems. All right, I will talk to you girls soon. Thanks, bye.